My name is NivethineM and welcome to the video presentation of my research proposal for the 4th year Psychobiology of Aging course at the University of Toronto, Scarborough. Today, I will walk you through a brief outline of the current empirical findings in this area of research, the gaps in this field, and how my study will address these shortcomings while bringing forth significant implications. The proposed title of my research is The Effect of Chronic Social Isolation Stress on Sleep Regulation in Aging Octodon Degus. Aging is naturally associated with a number of neuroendocrine changes, which result in altered sleep patterns, particularly with the initiation and maintenance of sleep. However, additional dysregulation can occur due to other factors such as an underlying sleep disorder, other medical illnesses, and stress, which can be psychosocial in nature. An evidence-based analysis conducted by the Ontario Ministry of Health and Long-Term Care found a high prevalence of social isolation in community-dwelling seniors who are not living in long-term care institutions. For those individuals who are age 65 plus, social isolation can come from both social withdrawal due to reasons such as a loss of mobility from aging-related disabilities, or social exclusion resulting from a loss of familial ties or spousal death. Such changes have been associated with a reduction in their subjective well-being and is often appraised as a significant emotional stressor. Chronic stress resulting from social isolation has shown to result in significant increases of plasma cortisol levels in humans, and this sustained hormonal release can lead to a hyperactivity of the hypothalamic pituitary axis. Through taking a neuroendocrine approach, we can see how the HPA axis contributes to the regulation of sleep. More specifically, a dysfunction of the HPA axis, where there is an elevation of cortisol production, has been described as the underlying factor in understanding many cases of insomnia. To investigate this, I'll be using a sample of rodents known as degus, which, like us, are diurnal mammals, thus providing us with a relevant model for sleep analyses. These animals reside in complex colonies composed of smaller family units, which closely parallel the social structures observed with humans. In fact, previous research has shown that isolation of individual degus from the colony induced a significant amount of stress in the animal over time. So, from a total of 28 male degus, 14 will be housed alone for 60 days as a chronic social isolation group, and the remaining will be housed as pairs to serve as a control. While adhering to the institutional and federal ethical standards, the animals will be tested daily for measures of sleep patterns and physiological indicators of stress. The quality of sleep in the degus will be elevated using wireless radiotelemetry. Using this, measures of REM length and number of sleep interruptions will be obtained from the visual analysis of transmitted EEG recordings. Daily stress will be assessed through a measure of basal corticosterone levels by extracting blood plasma samples during both the light and dark cycles. Finally, after the 60-day testing period, the animals will be sacrificed and an MRI-based brain volumetrics will be conducted to assess hippocampal volumes. It is hypothesized that degus who are denied social interactions over the course of the experimental period will present with greater plasma corticosterone levels in comparison to the control group. Moreover, these stressed rodents should present with abnormal sleep patterns and reduced HPA axis structural volumes than the control groups. Sleep dysregulation is comorbid with a number of psychiatric illnesses, and there is the possibility that a lack of sleep itself can further contribute to an individual's perceived level of stress, thus leading to a vicious feedback loop which can be extremely detrimental for an aging individual. Social interaction is a malleable variable which has the potential to be manipulated within a real-life setting. So if findings suggest social isolation contributes to a significant amount of dysregulation in sleep, then this could support for a push for increasing the funding of social support groups, community-based exercise programs, rehabilitation for physical ailments to help reintegrate individuals that have physical barriers, and even some technology-based programs. Thank you for taking the time to listen to my research proposal.